Okay, so again, we're going to start the moving the vertex of a parabola. And initially what we'll do is use a table of values, and then we are going to leave it behind. So even if you turn the first page on the back, we're going to summarize the findings from yesterday and what we do today. So then all you're going to be given is an equation, and you should be able to make a parabola using vertex and step pattern only. We're also going to, like we did at the end of yesterday, write given the equation, what the shifts or translations or vertical compressions, vertical stretches, like we called it yesterday. You can write it. We're also going to look at, if you're given a point, can you figure out the equation of the parabola? You're going to have to match, given an equation and parabolas, match them up. So lots of different kinds of questions. So today, our parabola, our y equals x squared parabola, has been changed at the end. So yesterday we did one, like example number 2, where it was negative and had a number out front of the x value. So the second example we're going to do is going to combine them both. Okay, so here you're squaring and then subtracting 2 at the end. So negative 3 squared is 9 minus 2 is 7. Negative 2 squared is 4 minus 2 is 2. Negative 1 squared is 1 minus 2 is negative 1. 0 squared is 0 minus 2 is negative 2. So now our parabola is not going to be, the vertex is not going to be 0, 0. So we have translated, or shifted, sometimes it's called, our parabola. So 1 squared is 1 minus 2 is minus 1. So again, we're going to see the symmetry. 2 squared is 4 minus 2 is negative 2. Positive 2. 3 squared is 9 minus 2 is 7. Okay, so we have made our table of values. Now we're going to graph the parabola. We're going to graph the points. So negative 3 and 7, negative 2 and 2, negative 1, negative 1, 0, negative 2, positive 1, negative 1, positive 2, 2, 3, 7. So I think this grid is a little bit better today, but again, if you want to emphasize for yourself where the x is, like this is 0, 0, and where the y is, please do that so it's more obvious on your note. Okay, so B says, starting at the vertex, find the step pattern. So yes, you can do the first differences, but again, after these two first examples we're going to move away from table of values. So I would use your graph, okay? So start at the vertex, we always go over 1, up. Sorry, that was terrible. Over 1, up 1, over 1, up 1, 2, 3. Over 1, up 1, 2, 3, 4, 5. C says, what do you notice from the original step pattern? So the original step pattern, if you forget what that is, that we wrote that yesterday, 1A, 3A, 5A. So this parabola here, are they the same? Have they been changed? What is it? Is it the same? Yes. So the original vertex, if you forget what the original vertex is, remind yourself. Okay, so it's always been 0, 0. Today, what is our new vertex? What is this point down here? 0, -2. Good. Let's write it as a point. Okay? So, when you have an equation like this, where it's -2, then the vertex, we call it, or you can say that it's been shifted down. So even before we do this, forget about this term for a second. When we look here, what do you think is going to happen to our vertex? If the other one was -2 and it shifted down 2, if it's +8, what do you think is going to happen? Yes. Up 8. Okay, good. So we'll Okay, so now we're gonna do 2 transformations, and then after lunch you'll be able to do 3, actually 1, 2, 3, 4 potential transformations. Okay, so now we're still going to do the table of values, and this is the last time. Okay, after that, you hopefully will be able to look at the equation, figure out the step pattern and the vertex, and draw the parabola. Okay. So let's make a table of values. So we're going to do -3. And remember to do BEDMAS. We have to square that first. So that's 9. But if there is space here, if you prefer to write it out. Okay, so -3 squared is 9 times -2 is -18 plus 8 is -10. -2 squared is 4 times -2 is -4 squared is, sorry, -2 squared is 4 times -2 is -8 plus 8 is, yep, -1 squared is 1 times -2 is -2 plus 8 is -6. It's okay. It's just one of those Japanese beetle things like the red and black. They're totally innocuous. They're just an invasive species. 0 squared is 0 times -2 is 0 plus 8 is 8. So like I think it was Kylie predicted, we are going to have our vertex now at 0 and 8 because it has shifted up 8, but we'll do all the values. But hopefully you don't need the table of values to do this at the end. One squared is 1 times negative 2 is negative 2 plus 8 is 6. Oops, 2 squared is 4 times negative 2 is negative 8 plus 8 is 0. And then lastly, again, we have 3 squared, which is 9 times negative 2 is negative 18 plus 8 is negative 10. So now we can make our parabola. And again, hopefully, I think this grid is good. You can see it. But if you need to emphasize for yourself that this is x and this is y, if you want to make those lines darker, you can, but it's not as bad as 5.1 was. Do a better job than me, okay, with on your paper. So we're going to do the same thing. Find the step pattern. Again, I encourage you to use your parabola and not the table of values because we don't want to use a table of values anymore. Yes. We did, yes, but I didn't make you graph them as much without a table of values. Now I'm just going to give you this, and you're going to have to, using the step pattern and vertex, graph the parabola. And we're going to do one more translation, and you're going to have to try to figure it out. You're going to have to write what we did, like looking at this. It is weak set open down. Now we're going to call it reflected in the x-axis. It's stretched, so those kinds of things. So you're right. So now we're kind of combining everything and doing a bunch of questions. Okay. So calculate a step pattern, sorry. So now we're going to go over 1. And this time we went down. So you can call that negative. And we're going to go down 2. Over 1, down 1, 2, 3, 4, 5, 6. Over 1, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when you do 1A, 3A, 5A, 7A, or now our original step our new step pattern is so we wrote it yesterday like this, 1A, 3A, 5A. So you can take, the way we did it yesterday, take the A value, which is negative 2, right? Anything in front of the x squared is A, and multiply. So 1 times negative 2 is negative 2. 3 times negative 2, negative 6. 5 times negative 2, negative 10. And the vertex has been shifted or translated up 8. Usually we say units, or often you'll see it's shifted up 8 units. Don't put it away. Okay, so this is one type of question you could have to do. Draw the parabola. You have to write about what's happening with the step pattern and the vertex. You could also be given a chart like this and asked to fill it in. What is the value of A? What is the direction of opening? What is the vertex? And what is the axis of symmetry? So again, this is the x value of vertex. So the value of A here is 1, not 0, it's 1. When you have a positive A, then the direction of opening is up. The original vertex is 0, 0. So the axis of symmetry, you use the x value. So this one is the base. Okay, so now when you have transformations to this basic parabola, so far we've done 2 of the, well, kind of 3-ish of the different types. So now we have a different A value, it's 2, and still up because the A value is positive. When you have a change in the A value, the vertex does not change. So none of these are shifted up or down. So they are all going to have a vertex at the origin. So what happens when you have a change in A value, you're going to change the step pattern. So again, one of the things you're going to have to do is write whether it is vertically stretched or vertically compressed. So again, if you don't like the alligators, when A is greater than 1, or it's not a fraction, it's a whole number, then we call it a stretch. And it's compressed when the A value is a fraction or a decimal. Okay? Doesn't matter. If you like the idea of having a summary on the same chart, then you can even add things here that we've already talked about before, like a positive A value. It opens up. It's supposed to be an O. Negative A, it opens down. And again, that'll be somewhere else. We talked about that before, but if you like it, if you want it to be all in the same place, it doesn't matter where, somewhere near this. You could even put on here as well the step pattern, 1A, 3A, 5A. So again, it's up to you, but if you like this, the information to be in the same spot, then write it in. I'll include 7, but normally, especially if you have a big A value, then the stretch is too much. Yes. Yes. Yes, and then whatever the A is, you multiply. So if it's 1, then it's 1, 3, 5, 7. If it's 2, then you multiply by 2. Yep, always. 1, 3, 5, 7. Okay, so then the next chart will serve as a summary for the second transformation that we did. So again, here's the base one. So what we're going to use is a general form of the equation. So depending on the source that you use, sometimes they use P and Q, and sometimes they use H and K. So your textbook uses K. The old textbook uses Q, but it doesn't matter. So when you have a whole number outside of the brackets, it could be a non-whole number, but we're gonna stick with whole numbers. So now, what is the value of Q? There is no number there, so it's not 1, it's 0, because 1 would still be a shift up or down if it was positive or negative. This Q value is 2, 4, -1, -3. And again, if you want to put here, your textbook uses H and K instead of P and Q. The new textbook does, but it doesn't matter. All of these have a positive A value. None of these have a negative out front of here, so they're all open up. Okay, so when you have a number outside of the brackets, then that is going to be a vertical shift up or down. So I'm going to get you to write that in first. So we're talking about a vertical shift. So if you're moving vertically, what's the vertical axis? Y, good. So that is going to affect the Y value of the vertex. So you always go from 0, 0. That's the base one. And then if it's a positive 2 for K or Q, then you would be vertically shifting up 2 units. So the new vertex would be 0, 2. The positive 4 means 0, 4. The negative 1, now we're going down. And the negative 3 means down 3. But we have not changed the x value, so the axis of symmetry is still 0. If it's positive, it goes up, negative goes down. So vertical shift up if Q is greater than 0. Again, if you can write positive and then less than 0 or negative if you prefer that. And again, your textbook is going to use K instead of Q. But no big deal. Okay, so here we have, again, two different kinds of examples. So you could be given the equation. So these are the ones we already did. But again, we're going to really try to move away from using a table of values. So if you have the equations, what's the vertex going to be? So this one is up 2, and this one's up 8. Axis of symmetry is the x value, so 0 and 0. This is positive, so up. This is negative, so down. And then decide for yourself if you need or want to show the multiplying work for the step pattern, or you can just write 1, 3, 5, 7, and then the second one is -2, -6, -10. Maybe you can just do it in your head. It's up to you, okay? Actually, there's a little bit of space here, so I'm going to show my work, okay? I know that it can be tempting to skip, right? Oh, I don't want to graph. I hate that part. That is why I included graph paper at the end of this booklet. Please, please, please don't skip the graphing, okay? So you have to now look at this equation, figure out what the vertex and the step pattern are, and that's enough to draw the parabola, okay? So, and in this case, we're going to draw it on the same grid. It's not always going to be like that, but to save paper, we'll do that, okay? So we have, it doesn't matter what you figure out first. So this one, when you have -7, you go down 7 units. So the vertex is 0, -7. The A is 0.5. That's the original one. So then this is, it's always going to be like this, 1, 3, 5, 7. And then, yes, except if it has an A value. So then you just multiply. So here, we're going to multiply by -3. I don't know what you mean. Yes, you always have a squared. So this one's missing a B term. So, but yes. So we've been dealing with the same sort of format, yeah. Like x squared, yeah. So this is a, is that what you mean? Yes. Same thing, yes. So same thing as before, yes. So this is c. So I realize that fractions aren't always nice to graph, but the most I would make you graph is half, okay? So do your best and estimate where half would be or 1.5 would be. Okay, so it's always over 1, up or down, whatever. So in this case, it's not negative, it's positive, so we're going to go up. So over 1 up half, over 1 up 1.5, over 1 up 2.5, you should label your parabola somehow so that you know which is which. I didn't leave room for B, so I'll write it down here. So now B, the vertex it's plus 10, so that means up 10. Our A value is now -3. So that means our parabola, you're going to go down instead. So when you think of step pattern, over 1, down, whatever. So if it helps, plug in the -3. Okay? So then this negative is telling you down. So over 1, down 3, 1, 2, 3. Over 1, down 9. And then make sure it's symmetrical. Over 1, down 1, 2, 3. Over 1, down 1, 2. I don't think we'll get the 15. So you can see when you do stretches, it makes it off the grid really fast, okay? But even though these parabolas, their vertexes have been shifted up and down, like in the vertical axis or y, the axis of symmetry is still x equals 0, right? They're still symmetrical about the x-axis. Yes. Yes. Pardon? Yeah, yeah. Okay, so what happens when we are going to shift it horizontally? So what's the horizontal axis? Good. So that means that we are going to now affect the x value of the vertex. So we are going to have a formula that's a little bit more complicated. X plus 2 squared plus 3. So when you do the table of values, so again, you're plugging this in wherever there's an x. So negative 2 plus 2 is 0, squared is 0, plus 3 is 3. Negative 1 plus 2 is 1, squared is 1, plus 3 is 4. 0 plus 2 is 2, squared is 4, plus 3 is 7. 1 plus 1 is 3, 3 squared is 9, plus 3 is 12. 2 plus 2 is 4, squared is 16, plus 3 is 19. So it's hard to see the grids, but when you graph it, it only goes up by ones, okay? So you can see this one's a little bit bigger because we want to get 2 and 19. Is this a parabola? No. So you can make it symmetrical. The step pattern here, it's over 1, up 1, over 1, up 1, 2, 3. So it's the normal step pattern. So you can do that on the other side. Over, up 1, over, up 1, 2, 3, over 1. So this time, the value of the vertex is negative 2 and positive 3. So we already changed the y value of the vertex. So the plus 3 moved it up 3. But now here, this positive 2, so this is what you would think, right? Up is positive, but here, when it's a positive 2, how did it shift or translate? Left or right? Was it positive 2, positive 3? No, it's opposite. So once we do this y-intercept thing, there are basically 2 slides of summary stuff, okay? So what happens when you do a translation, it's all related. No worries. It's all related to what we're going to call vertex form. And vertex form has a negative inside of it, okay? So what happens is when you have negative, negative, what do you get? Positive. Okay? So it is going to, when you do the horizontal translation or the x-axis shift, then you have to be a little bit careful, okay? So again, you're going to deal with vertex form. We're going to talk about that. We're going to see what it means. We're going to use that formula to find the equation of the parabola. So we're going to do a similar type of question over and over and over again. If you are asked for the y-intercept, so we need the equation in standard form. Right? Ax squared plus bx plus c. And which is the y-intercept? A, B, or C? C. Okay? So you have done a million of these questions. You're going to expand and simplify. Whoa. Okay? So decide how much work you need to show. So we have to FOIL. First, x squared, outside 2x, inside 2x, and last. So now we have the c value. Are there other ways to tell what the c value is? Or the y-intercept? Sorry. Another way maybe to do it algebraically. What could I have set x to? 0? You could have plugged in x as 0. You could have also looked on the graph. That's not always possible, but this is probably what you would have done in grade 9 was sub in x equals 0. This might have been more using standard form what you would have done in grade 10. Okay, so the next two slides, we're going to summarize what we've got, okay, so far. So this one, there is no change to this chart. There's no change to the vertical transformation, okay? It's not shifting up or down. So here again, this is the base parabola, and the old textbook used P, the new textbook uses H. If you want to change that or add that in, so you're aware that it could be either. So there is no H here. Up. That's the base one again. So remember, it's opposite to what you would think. If this is negative, then we're actually moving right 2. So the value of P is plus 2. And then if it's positive, you're actually going left. So now the x value is going to be different. So right 2 is positive 2. Right 4 is 4, positive 4. Left 2 is negative 2. And left 4 is negative 4. So then whatever you change your x value to, that changes the axis of symmetry. So this is part of vertex form, and the general formula is negative. So that's why when you have a positive value, it comes up negative in the formula, and when you have a negative value, it comes up positive because you're doing like a double negative, which makes positive. And you don't need to memorize vertex form. I'll give you what it is. I'll show you what all has to go in here. Or should go in here. And then if you want to change P to H or add it in, if you're a textbook reader, and then again, if you don't like the alligator signs, So this again, this is another important summary slide. So this is vertex form, okay, which is very, very important. So if the question asks you to write an equation for a parabola, I want you to use vertex form. So this is all of the transformations that we've done in one slide, okay? So the step pattern is changed by the A value. Then you can have a vertical stretch where the A value is bigger than 1. This is a compression when the number is a fraction or decimal. If its A value is negative, we say reflection in the x-axis. So if you just say opens down, that's not really good math form, okay? So if it's negative, then you should be saying reflection in x-axis. And again, even if I'm nice in grade 10, they won't be as nice in grade 11, okay? So if you have a p greater than 0, then you're shifting to the right. So it will appear to be negative, which this one is tricky because it's sort of opposite of what you would think. If it's less than 0, you're going left. So technically this is going to be a negative p-value, and this would be positive. But because the general vertex form is negative, so then when you put a positive number in here, it's just negative. But when you put negative, negative, then that becomes positive. Okay, so it sort of tricks your brain a bit. Whereas here, if it's greater than 0 or positive, it's up. Less than 0 or negative is down. And that's what you would think. So this is the one, this horizontal shift or translation that can be a little bit tricky. Okay, so these two questions are a certain type of question. So when you are asked to write about the transformations, I recommend that you just go in order, okay? So I'm going to use different colors to emphasize that. So here, this number affects the stretching. Over here, if it's a fraction, what do I call it? Yes. Can you say it louder? Yes. So when you're actually figuring out what the vertex is, it doesn't really matter if you think about the y value first or the x value first, as long as you get it right. But when you're doing the transformations, I would just go in order so that you don't miss one. If it says to write about the transformation and the question is out of 2, how many transformations do you think there are? 2. If it was out of 3, how many? Good. Okay, so you get the idea. So just keep going so that you don't miss one. So now we have a negative 3 in there. So inside the brackets is the horizontal shift. But now you need to decide, is it left or is it right? Kylie. Good. Yes, it's not what you would think. Okay. But the last one is, okay, so now we have the plus 4 is going to be the vertical shift, and it's plus it's positive 4, so that's up 4. So here, we actually have two transformations to talk about with the a value. So this is negative, so we say, what's the opening? It opens down. But when you're talking about the transformation, you should say reflection in the x-axis. So if you want to write a little note, that's because the a is negative. So we're not, if you're asked to write about the transformations, don't just write opens down, okay? It's a reflection. You're flipping it over the x-axis. That's what that means. Now we can go on to here. So what's the horizontal shift? Yes. Good. And then this one is down 7. Okay, so another type of question is you're given a bunch of parabolas and you have to match it to the equation. Put that away. So the easiest thing to do is really look at this and figure out what the vertex is. You can also look at whether it opens up or opens down. So this one opens down, and the vertex is positive 4, positive 5. Which is the red one. So this vertex 4, 5, and it opens down. This one opens up, and the vertex is negative 1, negative 5. It did. Oh, because it's opposite, remember? If it's positive, you go left, inside. So opens up, negative 1, negative 5, so that one's B. You could even use other information as well. So this 5 here means that it's a vertical stretch. So that's this, okay? That it looks skinny. Here, this one opens up. And so the x value becomes a negative 6. But what's the y value? Nope. 0, yes. So either you think of it like there's nothing here, so that's 0, or because there is no translation here, you go back to the original vertex value. So that's this one here. Negative 6, 0 opens up. This one's going to be down. Vertex is negative 8, positive 1. This one's up. So this is going to be to the right 7 and up 3. So that's another type of question you could have to do. You can also write your own equation. So remember, you're going to be given what vertex form is. So the vertically stretched by a factor of 6, that means the A is 6. Reflected in the x-axis, what does that mean? About the A value. Positive or negative? Kylie. Negative. And then it says shifted left 7 units. So now this is where you can actually, like, you don't even have to try to remember. So if you do shifted left 7 units, that's going to be negative 7, right? So you can even plug it in like that. So then when you have negative, negative, what does it become? Positive. Okay, so that's the reason there. Are we changing anything vertically? No. Yes? There is no Q, right? We're not changing anything vertically. So Q is 0. So you can either, again, go back to the original vertex where the Q is 0 and there's no vertical shift, so it still stays 0. Or if you look here, it doesn't describe any vertical shifts, so we don't put anything, no 0. Yes, Erica? Yes, like this. So then when you plug in negative 7, it becomes positive. Okay, so graph each using vertex and step pattern. This is what you're going to have to do every single time, okay? Doesn't matter really which one you figure out first. If you are sick and tired of showing your work, you can, but when I'm doing this example, I will show. So probably not going to get to 7 adjusted. So this is similar to when you would do y equals mx plus b, right? You had to show your work, slope and y-intercept at least. So you'd have to do the same thing here. We need the vertex and you need the step pattern. So this is going to be right 6 and then down 9. Okay, so positive 6, negative 9. When you do the homework, the graph paper at the back, I didn't give you grids like this, but on a test or quiz, I would, or the exam. So if your graph is not going to fit on the grid, then you have made a mistake, okay? Or you shouldn't do this, things like this, where you wouldn't get any values hardly. That's not going to happen. You have done something wrong, okay? So you can kind of check your graph a little bit. So 6 and -9. So now we're going to go, this opens up, it's not negative. So over 1 up 3, 1, 2, 3. Over 1 up 9. 9. And I don't think we're going to get to 15, which is fine. Make sure you have a parabola so it's symmetrical. So over 1 up 1, 2, 3. Over 1 up 1, 2, 3, 4, 5, 6, 7, 8, 9. If you have to draw two parabolas on the same grid like this, you must label them. If you don't, you'll lose communication marks because I won't be able to tell that you know which is which. Okay? So when it asks you just to graph using vertex and step pattern, you can definitely write it out, translation, horizontal translation, etc. But only when you're asked to describe the transformations do you actually have to use the math terms like that, okay? Because what you're going to get marks for here is what's the step pattern, what's the vertex, and did you graph it right, okay? So now we have a down parabola. So we're really not going to get very much here. And the vertex, so this time this is positive, so we're going left and up. When the step pattern is negative, should I be going up or down? Down. So over 1, down 4. Over 1, down 1, 2, 3, 6, 7, 8, 9, 10. Ooh, perfect. So yes, there are quite a few questions here, but again, there's lots of different kinds of questions you could be asked. So 2 and 3 are straightforward. Number 4, it wants you to write the transformations. I would just graph them. And then number 11, it doesn't say explicitly what to do, like what kind of form of the equation, but on your test in the exam, you're going to use vertex form. So when you write the equation, you always use vertex form.